Okay, dear friends, welcome you all on my channel Varteta Learning Platform. And today we are going to discuss one binary search tree related algorithm where we have to find out the kth smallest and kth largest element. So basically, it's an order statistics operations performed in binary search trees. So many questions are asked on these things in your interview, and these are very important as well when you are developing some application. You may need these kind of things. So you need to know this kind of algorithm, that how you can implement it. All right, so here I have taken example to find out that what is the third smallest element and what is the third largest element. So that is just for a sample, and you can just extend that logic to make it work for any element. I mean, kth smallest and kth largest. I mean, you can make it generalize. But in this video, I will give you an example with the help of the third largest and third smallest element. Okay, so let's see how we can do that. This is the array in which I have all the elements which using which I will be creating my binary search tree, and insert node is the function that I have written here on the top. This function is basically here to insert the nodes in a binary search tree. So I'm not going to explain it to you because this has been explained earlier. And in the same playlist, you can go and find out that how you can do this. And then what I will do, I will just find out the third largest and third smallest number in the binary search tree. For that, I have already written these two functions, and I will explain these two. Okay, but before that, I would like to remind you one property of binary search tree traversal, which is the in-order traversal of a binary search tree. I already told you that this is the in-order traversal. I already told you that if you will do the in-order traversal of your binary search tree, then all the elements will be listed in some order, in the increasing order, right? So it's like you first visit left, then you root, then you visit root, and then you visit the right element. Okay, right child. So let's see what happens here. This is just an example, just to remind you that what we are going to do. So in the in-order traversal, you can see that all the elements will be arranged in increasing order, right? But if I do a slight change, like in place of left, I put it right, and in place of right, I put it like left, then what will happen? Okay, so in this case, all the elements that are listed in the increasing order, they will be listed in the decreasing order. I have already explained in one of my previous videos. So here you can see it's like 25 to 1. It's all in the decreasing order of elements. So this is the way you can do the traversal in order manner. And if someone wants, like if you want to arrange the elements in the decreasing order, then you can do like this, right, root and left. And if someone asks you to arrange these elements in the increasing order, then you need to do left, root, and right. So this is the way you do this. So I just written this in order traversal function just to show you the concept, and I will use that concept to find out the third largest and third smallest element. And many of you might have already found it out, like what I'm going to do. Okay, so what I need to do here, I have taken two variables. One is k, which will be maintaining the number of elements that I have visited, and this the second element is n, where I will store the kth largest or kth smallest element, whatever I am doing here, right? So whatever I am searching for, like here I've written a function which will find out the third smallest element and the third largest element in the binary search tree, right? So what I have done here, if I have to find it out, what is the third smallest element, then what I have done, I have just written the same logic that I have written for the in-order traversal. I mean left, then root, I mean the visited element, and then the right. Okay, but when I'm visiting the root element, when I'm visiting the node, then what I'm doing here, I'm just increasing this k. I'm increasing it this k and making it k plus plus, right? So once the k becomes 2, what I'm doing, I'm just storing the number here, n is equal to p root to data. So after storing it, I can just return it from here, and I don't need to do any more kind of operations like moving to the right or moving to any other node. So just write a return here, and this will be working for you to find out the third smallest element, right? So every time I'm increasing k plus plus, I'm increasing k, and at the same time before that I'm checking it if k has become equal to 2, I mean I have visited the third element. So if I have visited third element, I am simply storing it in a variable named n and just returning from here. Apart from that, you can do one more thing. You can just do like n is equal to 2, then sorry, not n, it's k. If k is equal to 2, then you need to return it from here. So you can see that it's the same logic which I have used for the in-order traversal, but here I have done a slight change as per our needs. We have to visit the third element, so I have traversed the binary search tree only for the 3 times, not more than that. So let's see, let's call the function. What is the function name? It's find third smallest element, and here I'm going to give the root of the binary search tree, and after that I will just print it, endl, and here I will put like p root to, no, not p root, it's n, because in n I'm storing it, so it will be n. So let's see what does n prints. So control F5, let's see what happens. Okay, so okay, just let me remove this logic because this is not needed here, otherwise it will be returning before reaching to this place and it will create problems for us. Okay, so this logic was not correct, only you need to write here, right? So here you go, and what you need to do now, you just need to run it. And what I need to do here, okay, just remove this return as well, and let's see what is happening here. Okay, so you just don't need to print it. I'm not sure from where it is getting printed. I have just removed it, but still it is printing. That's strange. Let me just recompile it, rebuild it, and then we will see what is happening here. Oh, okay, so here I'm printing it. Okay, so let's just find out the third smallest element, and let's see what it gives to us. Okay, it gives me 3. Still it is printing. I'm not sure what I have done here. Okay, here I need to remove it. I'm using this function, so just need to run it again, and now this time we will be able to see it's 3, right? So if you see in your array, then the third smallest element is 3. 1 2 3. So just don't need to use this return. If I do the return, then there is some problem, but that should be with the top one, not with this one. Okay, so let's see the output. Okay, so it's giving the trouble. You cannot do this. In fact, you should do all these things after this statement. If k is equal to 3, then no more iterations. Just return it from here. Okay, so just go with this. Okay, now it's fine. So this is the way you can find out the third smallest element, and similar logic, the same logic. In fact, I should say it should be in the third largest element. The only difference would be you need to start from right, then root, then left. Alright, so here you need to write like if k is equal to 3, just need to return. So this time we will just find out the third largest element. So the third largest element is like 25, then 21, then 19. So 19 should be printed when I am using this function, third largest element. Alright, so here I need to call this function largest number, find third largest number, and here also I need to write this third largest number. Alright, so this way we will be able to store everything in n. So before calling it, just remove it and write like find third largest element, then pass the root, and then cout, just print n, and let's see what happens. So it should be printed as 19. Okay, so it's not printing 19. Why it is not printing it? Find third largest number. It's large it. No problem with that, but why it is not printing? Okay, so it is not an issue. So find third largest number. For that, what I'm doing here? Why it is printing 25? Okay, let's see why it is printing 25. So it's like if I am okay, let me just put a breakpoint here. F9. Oh god, I'm not sure why this stops working when I want to create some video. It's really a pain for me. Whenever I start working on a video, it stops working.